Hi guys, welcome to Learn at Home. I'm Siddharth and today we are going to talk about pressure measurement part 3. Before going any further, I want to tell you this is the English version video. If you are a Hindi listener, you can click the link given below in the description and you can access the Hindi version too. So let's continue to our English chapter, pressure measurement part 3. As you all know, I have classified my pressure measurement chapters in 5 different categories. And this is our third and important category, that is pressure transducer. And so I have parted my pressure transducer in 3 different categories. First is diaphragm type pressure transducer, second is piezoelectric pressure transducer, and the third one is pressure sensitive paints or PSP. So let's move on to our first diaphragm type pressure transducer. Before understanding diaphragm type pressure transducer, you have to understand what is diaphragm and how it works. So if you want to know this, you can click the link given below in the description about pressure measurement part 1. I have talked about this diaphragm in detail in this part. So now let's move on to our pressure transducer. Uh, if we carry this diaphragm type pressure transducer, we have to understand 3 different categories. First is capacitive type pressure transducer, second is inductive, and third one is ohmic or resistive type pressure transducer. In this image, we are showing a capacitive type diaphragm pressure transducer. As you can see here, in every capacitor there are 2 plates. So we are using our diaphragm as the second one plate. First is a normal plate and second is our diaphragm. When we apply a pressure on this diaphragm, as you can see this dotted line, this is our curved diaphragm. So the capacitance output will be changed, and we can calibrate this capacitance output to our electrical signal, and that can be calibrated to pressure. So here is the catch, that we are using a diaphragm we are using a diaphragm as the capacitor, as a capacitor plate that can give a change in output when we apply a pressure. So we can calibrate this output to our pressure, input pressure. So this is the most important and most usable form of this diaphragm type pressure transducer, that is capacitance. They're mostly using in every type of transmission and every type of transmitter, in the industries. Mostly we are using the capacitance type transducer in every transmitter in industries. So understand it. The second and the most important is inductive type. Here you can see a assembly in this image. Here is a diaphragm. You can see here this is a pressure port. When we apply a pressure, this diaphragm deforms, and it can move this LVDT plunger. As you all are familiar with LVDT, linear variable differential transducer. So here is the catch: when we apply the input voltage to this primary coil, the secondary coil will generate a differential voltage output. When this plunger or this core moves, so when we apply this pressure, this core move and the output voltage will be changed. So we can read this output voltage and we can calibrate it in the form of pressure. So this is also an important type of pressure transducer that is made by diaphragm. The third one is resistive or ohmic pressure transducer, that is made by diaphragm. So normally we used a strain gauge on the diaphragm. We can place a strain gauge on the diaphragm. When diaphragm deforms, it also deforms the strain gauge, and you all know when the strain gauge deforms, it can change it changes its resistance. So we can use its resistance in a bridge form, and we can get the differential output. So we can also use the diaphragm as resistive pressure transducer. So we all read about capacitive type differential pressure transducer and resistive type and inductive type. So now let's move on to our second piezoelectric pressure transducer. Before understanding piezoelectric transducer, we have to understand piezoelectric crystal. There are many types of piezoelectric crystal, and the most important piezoelectric crystal is quartz. Actually, when we apply a pressure on a piezoelectric crystal, it can generate a potential difference. It can make a voltage signal. So we are going to understand this piezoelectric transducer in this part. So the main principle of piezoelectric transducer is that a force when applied on a quartz crystal or any piezoelectric crystal, it produces an electric charge on a crystal surface. Okay, understand? The charge thus produced can be called a piezoelectricity. Okay, that piezoelectricity can be defined as the electrical polarization produced by mechanical strain or on a certain class of crystal. The rate of charge produced will be proportional to the rate of change of force applied as input. Okay, as the charge produced is very small, a charge amplifier is needed so as to produce an output voltage big enough to be measured. The device is also known to be mechanically stiff. For example, if a force of 15 kilonewton is given to the transducer, if it may only deflect to a maximum of 0.002 mm, but the output response may be as high as 100 kilohertz. You can understand this is a very big unit. So this proves that the device is best applicable for dynamic measurement. Okay, and this now move on to this figure. This is a pressure port. When we apply a pressure, this is a force stemming membrane, and when we apply a pressure on this, the crystal deforms and generate a output voltage. Okay, now let's talk about what is the advantages of piezoelectric crystals. As we understand in previous example, it is very high in frequency response. Okay, self-generating, so no need of external sources. Simple to use as they have a small dimension and large measuring range. Okay, barium titanate and quartz can be made in any desired shape and form. It also has a large dielectric constant. The crystal axis is selectable by orienting the direction of orientation. Okay, so many advantages. Now talk about disadvantages. It is not suitable for measurement or static condition, because you all understand, as we have talked in previous slide, that it is giving a very high frequency range. And let's move on, sorry. Since the device operates with a small electric charge, they need high impedance cable for electrical interface. The output may vary according to the temperature variation of the crystal, so it's more important to fix the temperature. The relative humidity rise above 85% or falls below 35%, its output will be affected. So we have to manage its humidity also. So we coated it with wax or polymer materials. Okay, understand? Now let's talk about pressure sensitive paints, PSP. What is pressure sensitive paint? Actually, pressure sensitive paint is a paint which emits illuminates when we apply a light source on it. So we are going to understand in detail what is it, because usually in aerodynamics we are using this PSPs. Okay, as you can see in this image, when we excite with this a light source, its luminescence output will be getting VR, and here you can understand very we are giving a illumination source with short wavelength excitation. Okay, most important thing. And here is the photo detector, that is long pass filter. This is PSP, and it's giving a output illumination that can be read with photo detector. Why and how it works? Sorry. Model surface is painted with the PSP coating with an airwash or automotive type. This is an example for understanding the PSP. Okay, so just focusing what I'm saying. Just focus on this. The PSP consists of an oxygen sensitive probe suspended in an oxygen permeable vinyl. The model is then placed in an oven so the PSP layer can cure. Once cured, the model is placed in the wind tunnel to appropriate test environment. LED lamps of a specific wavelength are used to excite the pressure-sensitive probes within the paints. So we are talking about probes, okay? And what type of probes? We are using oxygen permeable binder, that is contains oxygen molecules, and that probes are used to emit or illuminate after we are getting a source light from anything with fixed wavelength, so it's illuminate, and we can read the output by photodiodes or photo sensing devices. So in this example, when we do this, output voltage will be generated, and when the pressure applies, the output illumination quantity will be changed. And how it's changed we are going to talk about. When we apply a small pressure, it illuminates with high sensitivity or high, it's generate photon with high accuracy, and when we apply a high pressure, it gives a less output illumination. Okay, more pressure, less output, less pressure, more output. Okay, why we use this PSP in our aerodynamics, and why we use this? If before this PSP we are using mm, pressure tap arrays. Sorry, before this PSP we are using pressure tap arrays. We apply many pressure taps on the surface with uh, or this array. We can measure every different pressure tap or with a different pressure. So in our complex design, it's very hard to make a pressure tap array, and it's very costly too. But in pressure paint PSPs, pressure sensitive paints, we use every pixels of this paint image. We are getting an image output. We can capture with any pressure sensitive cameras that we are using in this aerodynamics field. We can capture the image and make an output, so we can make every single pixel as a pressure tap, so it's giving a very accurate output and less in cost, or we don't need to make an array or any complex assembly, so we can easily make it and less time taking, so it's very good. Now what is the advantages of PSPs? The greatest advantage of new technology is its much reduced preparation time compared to installing an array of pressure taps. As you can understand, it's just only paint, so we can spray it or just brush it, and you can make a pressure sensitive paint. And if you want to install a pressure tap arrays, you have to install every pressure tap and make it an array. It takes a very long time and so much cost. The same model can be used for other testing, such as load bearing test or radar reflection test, since the PSP will not interfere with other preparations or setup. So there are far more data points than other methods. There is essentially a pressure tap at every pixel instead of being limited to the actual pressure taps. So as we can understand, every pixel is giving an output, so it's more reliable and more accessible, and also we don't need any complex array, and it's don't have any limit, because when we using pressure taps we can use a limited pressure taps, so we have counted parts, we have counted outputs, so they are limited. But when we use PSP, there are unlimited points where we can measure the pressure or pressure change. So thanks for watching. If you want to learn our fourth and most important chapter, you can click the given below link or just go to our industrial instrumentation library, and you can access the video from there also. So keep watching our channel and don't forget to subscribe and like this video. If you like this, subscribe this, you can get further videos as well as. So thank you so much for watching.